Okay. Hi, everyone. Good morning. Who was here in my talk yesterday? Okay. So we'll cover some of the things, but not all of them again, because I don't want you to get bored. This is the C++ unit testing talk, good, bad, and ugly. And before that, a few words about myself. My name is Dror Helper. I am a developer and consultant working at Code Value. I specialize in unit testing, TDD, BDD, clean code, how to write your code better kind of stuff. I also write quite a lot of code in C++, Java, and .NET languages. I also have 2 courses in Pluralsight, both of them in C++. First of which is C++ fundamentals using Catch, and the second is deep dive into mocking with Google Mock. I have a blog at helpercode.com, and you can reach me on Twitter using Dror Helper. Anyone here is also a .NET developer? Okay. Have you checked out the Oscode booth down? If not, oh, excellent. If not, you should. It will help you debug your code. So let's start. Let's talk about C++. I love C++. I think it's a great language. It's an amazing language. It gives me so much power. It's, in my belief, it's the only truly multi-paradigm language. You can write anything from procedural code to functional code with object-oriented and meta-programming in between. On top of that, it's highly performant language. You have the ability to change the way the memory works and how your object works. With a single keyword, you can make your code move completely different. You can access the GPU and the CPU, and the compiler on top of that will do optimization we can only dream of in other languages. It is a multi-platform language, and it doesn't matter what other languages, starting with the J, says, they are not truly multi-platform like C++. And I have worked in a project in which we've created an highly performant multi-tenant voice over IP project, and the core of it was C++, and it worked flawlessly on any single operating system and platform, from ARM and Android to iOS, Windows, Linux, Mac, you name it. C++ will give you that. If you can compile your code, you can run your code. And it behaves well with other languages as well, because we are not snobs. We can call Java, and Java can call C++, and .NET can call or be called by C++. And Python can call C or C++ in a way, which make it really useful language to have, because we can rely on old code, which works to this day, and use it with new languages. And it has so much power. We can extend the language using macros and templates and type defs and other capabilities. And if we really want to, we can do low-level programming, either the GPU or write inline assembly, or decide whether or not that specific bit of memory will be allocated or deallocated, which gives us a lot of power. And on top of that, this is the language in which the development world was written. Compilers, operating system were written using C++, even some languages which has compilers that are not written with C++, that compilers were written with C++, or the platform or the runtime or whatever is C++. And that's very powerful things to have, because if we think about it, we can understand how they work, because we wrote similar codes. Unfortunately, with this great power comes great responsibility as well. C++ is not an easy language to master. It's a language in which you can cause a lot of pain and problem easily, without intending to. You can take a junior developer, give him C++ code, and say, well, good luck, because he'll probably have some memory allocation problem or dangling pointer things, and it'll create a big mess. And C++ requires us to know exactly what we do and understand how the language behaves. And if you've been to the talks about C++ 17, so it's completely over my head topics there about when to use EXISPR and other keywords that change completely what the language does, and you need to know the out-of-order execution and whatever happens in specific processors in some cases, if that's what you do. And that is a bit of a problem, because we humans make mistakes. But the solution, at least I found, that there's one good solution to that mistake, and this is the topic of the session. And those are those unit tests. Because unit tests enable me to catch at least the simple mistakes, which tend to happen quite a lot. Unit tests enable me to write code I have full confidence in. It helps me to catch the stupid bugs. I forgot to allocate memory kind of bugs. I accidentally went over the boundaries of the array kind of bugs. Because if that bug exists in the code, you will catch it with the unit test. It won't give you system-wide bugs, but it will help you submit code for testing that will not crash immediately. And that's a good thing. On top of that, it will give me the early feedback. When I was beginning my C++ journey more than 10 years ago, I would write my code, submit it for testing, throw it over the fence, go home, and the poor tester, will run my code, and it will crash immediately. It will throw it back at me. And with unit tests, I don't need to do that anymore. I get that early feedback. I know that I wrote the code the right way. I know that my code does not crash when executed in a most trivial way. On top of that, it helps me understand whether or not I wrote the right theme, not just the right code. Because some of the time, we are developing something, deciding to develop a feature, going in that direction, but on the way, we think about something completely different, and accidentally, or not intentionally, we develop something completely different. Once I get to test that code, I'll find out I developed the wrong feature. I don't forget features with C++ as well, but with unit testing as well, because all I need to do is to write a test to remember that I forgot to implement that specific feature. And the big selling point of unit tests are regression. Because once I get a good unit testing suite, it means that if I accidentally, when fixing a bug, create another bug, it will be caught by existing unit tests. Unit testing is also a good way to do design, either by doing test-driven development or behavior-driven development, writing your tests before your code, or if you decide to do it the other way around, write the test afterwards, you have to think about design, loosely coupled design, object-oriented design, how the dependencies interact with one another. You have no other choice because you need to test it, and you need to think about those things, and it helps you write very modular, very loosely coupled kind of code. And on top of that, unit testing are good documentation. When I go into a new open source project, sometimes the documentation is not so good, but most open source projects these days have some form of unit test. And by reading the unit test, I can understand what the author thought about how you should use your code, how you should run it, what you should do with it, what are the valid or invalid inputs. And you can debug those documentation as well. It's not like a Word document or a Markdown document, which we all probably use these days. It's something I can actually run and see execute and understand how the underlying system works. And when I write unit tests, I know something that in 2 months' time, in half a year time, in 1 year time, when I go back to that code and I forget everything about that specific piece of code, I can run the unit test and remember how I intended other people to use it. So unit test is a cool thing to have. Now, what is this unit test? There are many definitions. By the way, this is my own. And a unit test essentially is just a method. That's it. No more, no less. It's a method with specific other rules or similar to rules to how we write other methods in our production code. And there are some rules that change when you write unit tests from when you write production code. The first of which, that a unit test tests a specific piece of functionality. A specific piece of functionality is the other way around from how we write production code, because if I'll write a method in my code that's supposed to solve some problem, and I'll just solve one scenario, one specific path, if the problem, I'm not doing my job. But in unit tests, if I'll try to test too many things, I'll probably write an unmaintainable, unreadable test. So it has to test only a specific functionality, and it has to have a very clear pass or fail criteria. And the reason I'm saying that, because I was in a client, and they told me they are doing unit tests. Now, terminology may vary between companies. And what they mean by unit test is that they have this huge script that runs on 2 different big databases and does something. And in the morning, a tester will come in, and about until lunch or afternoon, depending on how much work he has, he will read the result and decide whether or not the test actually passed. And that's not what we want. I don't want to check the test. I want the test to tell me whether or not it passed or failed. And finally, unit test. Question? No. Finally, unit test should run in isolation. What do I mean? I don't want any external dependencies in my unit test. I don't want to call a server or file system or other external things outside of my control. I do want to do that in a different kind of test, which I write in a very similar way, which are called either integration test or scenario test or acceptance test, and that's okay, but I'm talking about unit tests at the moment. And the reason I want to do that is because I want those tests to run fast. I want to run thousands of tests, and I don't want to be about half an hour to run all the tests. And I don't want the test to fail because of some external dependency. I don't want the test to fail because my database doesn't have the right permission or the right data right now. When that happens, the test will start passing or failing without any reason, without any code change. And a test that passes and then fails and then passes again and then fails, what usually happens is that the developers will run the test again until it passes. And then quickly, they'll get used to the test being failing from time to time, and then all the time, maybe. And at that point, probably they'll stop noticing when other tests fails. And when those tests start to fail, and nobody cares about whatever runs there, you can delete all your tests because they do not matter anymore. So you have to be very careful with those tests who sometimes passes and then fails. You should delete them or change them because they will only hurt you in the long run. And this is a unit test written with Google Test. I'll show you other unit testing frameworks. In the C++ world, usually, but not always, or there are many options, I need to define this method, which is a unit test. And in Google Test, I do it using this guy. This is a macro, which all C++, veteran C++ know because it's in uppercase, right? And that macro does three things. First of all, it defines that I am going to write a method. The method name is in Google Test actually this. The name of the test is the method test. It will create a method in the background. It will also create a class if it needs to, and the name of the class is this guy, movie test. So in the background, what we essentially have here is a class with the method inside. And the interesting part is over here. This is the test body, which, if we do our work correctly, is divided into three parts. The first part, known as arrange, is the part in which I create all the dependencies and things I need in order for the test to run. The second part is the act where I'll run the actual functionality I need to test. This is like a play button for the test. And the last one, also known as assert, and that's historically, because these days some unit testing frameworks does not have assert, I have other words for it, and in which I test the result. And if you know the movie, The Good, the Bad, and the Ugly, you might even know the scene I'm testing you. So that's Google Test, and that's fine. Other than the unit testing framework, I might need other tools in order to succeed with unit testing. The first being unit testing framework, but the second in which is a mocking framework. A mocking framework is something we'll talk about later on. I will also need some additional things that will help me write my tests quicker and execute them, and maybe get some information. Not mandatory, but very useful to have a code coverage tool that will show me what I'm actually running. And this is C++, so I don't always have it, some form of development environment, an editor in which I write my code and my test. And if I have that, I need to run my test from within. If you're working on Windows, anyone here work in C++ and Windows? Okay, so we have Visual Studio, good for you. If you work in Linux, you can use Eclipse or one of the other options. I've been to a company, they used an overglorified Notepad for Linux, couldn't run their test or their code, and that's a problem because you want to run your test all the time. You want to make a change and run the test, see what's happening. You want to debug your test. That's very important. Other than my own development machine, I also need a continuous integration server, a server which will run all my tests whenever I make a change, whenever I commit a new change. It's very important. I'm not going to talk about that today, but without that, succeeding with unit testing is hard to impossible. If there's no one else that runs your test will stop working after a while. And Every developer, we all developers, we know we have time limits, and we have stressful times at work, and sometimes we forget to run the code, sometimes we forget to run the test, sometimes we do it intentionally because we don't have enough time. And even if I have enough time and I run all the tests all the time, if you do that, you're a better man than me, because I don't do that. I forget. Even if I do that, this is my development environment. It's dirty with dependencies and all sorts of stuff I need to install in order to work with my machine. And I need a build server that will be very similar to whatever the client is running in order to make sure that my code runs in as close condition to what I'm writing as possible. So I need a build server to run the test as well. So what do I need for my unit test? 3 things for my unit test. First of which, a unit test will give me tests, the ability to write tests, and organize them in some form or way. In the past was known as fixtures. There's a lot of changes in C++ these days, so fixture is not a good name, but I don't have anything better. But the idea is to organize all the tests in some form of logical unit. And another thing I need for my unit testing framework is assertions, the ability to check whether or not something that I did just worked or didn't work. And lastly, some way to run the test. And especially in C++, I want to run all of the tests I've just created automatically. I don't want to create like a console application in Windows and then write all the test name in order to run them. I want it to run my test. And most, if not all, unit testing framework will give me that ability. They will also enable me to change how the tests are run using command line arguments. And that's important. More than that, there are some unit testing framework that has integration inside your development environment, especially in Visual Studio, since Microsoft opened the ability to do that in 2012. So that's a cool thing. I can run the test from within Visual Studio, and that is also a very nice capability to have. Yeah. So in the C++ world, what options do we have? By the way, there are many unit testing framework in the C++ world with many different kind of capabilities and styles. And that's one of the things that differentiates C++ from .NET or even Java. The styles of C++ unit testing framework changes from framework to framework because people have been do amazing things and have been taking the language to the limit and do cool stuff with unit testing. If you go to the .NET framework, to C#, all of the unit testing framework look exactly the same, just like JUnit in C#. There are some changes, some minor changes between them, but you know one, you know them all. It's not the case in C++. In C++, I guess people are more open to experimentation, to trying things out, so you have a lot of options and a lot of style to choose from. That's the good thing. The bad thing is that you don't always have documentation. Many of those projects are open source projects, and as such, that's someone who does his work late at night after working for 10 or more hours writing code, and sometimes documentation is not a priority. Another problem is that not all unit testing frameworks are actively maintained, and we need to be careful not to choose some unit testing framework which we can't get support for, or some of them don't even have the source code, and then we can't even support ourselves. And the ugly thing about unit testing framework in C++ is that deployment. And luckily for us, that's not always true, but deployment can be a problem. And another thing, if you worked in C# or Java, you might know that those unit testing framework, those mocking framework, use reflection heavily. They use reflection in order to understand what to run and how to do it and how to change the objects, and we don't have reflection in C++ yet. Nor will we have in 2017, probably, I don't know when we'll have it, but we don't need that. Because in C++, we don't need reflection. We have so many other ways to do stuff that we don't need reflection in C++. We have macros, and we have templates, and we have inheritance tricks, and we also can play with the build pipeline. And I was also involved in a mocking framework for C++, which used some project from Microsoft that enable you to redirect code running right now in C++, Windows only, unfortunately, Not sure about the state of that specific project, so I'm not going to show it. But you can do a lot of stuff, a lot of tricks using C++. It's a very powerful language. So, quick overview of some of the C++ unit testing frameworks. There are many, many, many more. The first one I want to talk about is Google Test. Google Testing Framework, one of the first testing framework created by Google, obviously, and come bundled with Google Mock. Google Testing Framework requires you to build it in order to use it, which has some problems because you need to compile and build someone else's library, and it has to be exactly like your library. It has to be the same configuration, the same platform, the same everything, multi-threading compartment, whatever. Otherwise, you get weird and funny linking problems. Another thing from a big company is Microsoft Native Unit Testing Framework. Microsoft Native Unit Testing Framework is not multi-platform, it's Windows only, from within Visual Studio. Been around since 2015, and you have it either in Visual Studio 2015 or 17. Documentation is improving, let's say it like that. And it doesn't have a lot of the capabilities of other unit testing framework. In fact, I think that they are recommending Google Test at the moment, but I don't know. You can use it, and the good thing is deployment, because if you use it in Visual Studio, Windows only, C++, just a matter of creating a new project. So that's a good thing. The third in line is Catch, written by Phil Nash, sits here. Very innovative unit testing framework. Very excited he's here because it's my favorite. He has thought about things we didn't know we want in a unit testing framework, and now everybody's copied it. Everybody takes his idea back and changing them. It's a header-only deployment, which means all you have to do is include a header file and you have a unit test. That's it. You don't need to build, compile, anything. That's cool. CPP unit, I need to remind you of the granddaddy of them all. CPP unit was created in order to write a book called Working Effectively with Legacy Code. It's a C++ unit testing framework. It's quite old. I don't recommend using it. It's behind the times. But you should know it's out there. And I have seen people use it, especially in the embedded space, because it doesn't use all the cool C++ 11, 14 kind of features, so can be compiled to that space. There's boost.test, which comes part of the Boost library, which you can use as well. I find it to be very verbose. I don't like to write too much code if I can avoid that. And there's doctest. Doctest is the first catch derivatives. They took the ideas from catch, and they changed a few things as long as the syntax, but they have a different idea. The idea of doctest is to write the test as part of the code in the same assembly, in the same place as the code, and during build you can use a flag to make all that code disappear, not compile. And that is an interesting idea. I'm not sure what I think about it at the moment. I haven't had a lot of chance to play with it, so I don't know. But that is a nice idea, especially since in C++ we don't always have the ability to look inside someone else's library and test the same code. So it might be good for some scenarios. There's lest. Lest is another catch derivative. He took the ideas from catch and from other unit testing framework and tried to improve runtime and compile time. But a few things got lost on the way because in order to improve that time, the tests are no longer automatically discovered. It's not exactly discovered, but registered. And so you need to write it by hand. It looks, if you know catch or doctest, you'll probably feel at home because it looks very similar. There's XUnit++. If you know XUnit from .NET, the idea was to bring the same ideas into C++. Unfortunately, it seems that it's not maintained anymore. So, but it's nice to have the same syntax. And finally, there's Metal. Metal is a nice way to scare Java developers. I'll show you it. But you might like the syntax. Okay. And it's a cool unit testing framework. It's not bad, but and you need either to compile it or use the header only, and then you have limitations. And in order to compile it in Windows, you might have to jump through some hoops. It's a more Linux thing. Let's see a few of those. By the way, this specific project is in GitHub under Dror Helper. That's my name. And here I have a few unit testing frameworks. So let's start with Google Test because it was the first. And we are going simple first. This is Google tests. And here I define the test. I can define the class, the fixture where the test runs, and the test name. And then I write the test body. Now, Google Test has an extensive set of asserts. There's quite a lot of ways to ask what I want to know. There's asserts any throw and def. It also can check that your application crashed. That's C++, remember? And exit and false and float and greater equal and less equal, don't equal, pre-define predicate. You can define predicates. And string equal for whatever collections. And there's also the way to use Google mock matches, which are essentially predicates that you can either write or use Google mocks in order to add even more assertions. I'm not sure if it's a good or bad thing, but we'll get to that later. And here I have a simple test. I'm testing the bowling kata. The bowling kata was invented by Bob Martin, Uncle Bob. And the idea is to build slowly a bowling game score calculator. And here, for example, I check that if I'll roll 20 times, I roll just one pin, then in the end of that, the score will be 20. Now, this nifty thing here is something I need to talk about. This is JetBrains C++, ReSharper for C++, enable me to run catch and Google test, which is nice, because the other option is to run it from the command line. And I can take this test and run it, and hopefully, if everything compiles, I'll get the result. It passes. And if I'll mess it up a bit and ask it for 21, I'll get a different result, which should be a failure. And the nice thing, the first thing you want to do when you have a new unit testing framework is to check what happens when it fails, when the test fails. Because when the test fails, you want as much information as you can possibly have. I only write unit tests in order for them to fail. If they pass, I don't care. That's a waste of CPU. If I had one way to find out whether or not a test will pass throughout its lifetime, I will delete that test. I just care about tests that fails. And when they fail, I want to know as much as I can. And Google Test is one of the testing frameworks that give me a lot of information. Remember, that's C++. You can get the actual method name I'm running and the result. And the nice thing about Google is that usually in other languages, you have to be careful which value you put in the left side and which value on the right side. And it's usually backwards. First you tell what you expect to happen, and then you give the actual result. And I find it to be the other way around. I usually say I equal 5, not 5 equal I. Although C++, some people are used to the Yoda notation, right? In order not to accidentally put a value instead of comparing it. But in Google Test, they don't care. They don't care which side you care about. They'll show you it in a very nice message. Moving on to Microsoft. Microsoft Unit Testing Framework will remind you what you are familiar from the Java worlds and the C# world. We have a test class, which a name, and you can actually see the test method. It looks just like writing a class. And I can have fields in that class. Again, not sure whether or not that's a good or bad thing. And every test method does something. And that's Microsoft. That's not an executable. Unlike the other unit testing frameworks, you can only run this specific tests using Microsoft tools. So either you open the Test Explorer from the side and you can see all the tests and run them from here, or in the command line you need to run Microsoft MS Test executable with the test as a parameter. But it's for those who like this kind of syntax, that's okay, that's fine. We have initialization and method and whatever. And moving on to catch. In catch, we can do a bunch of things. First of all, a test called test case, but not in that very similar. But the cool thing is this. This I like. I don't need to write a test name that is actually a method name. And when you think about it, it wasn't that hard to do in Google Test as well, but they chose the way that everybody did it. They didn't think how to make our life easier. When I can write a string as the test name, it means I can describe exactly what the test does. And when the test fails, that the first thing I see is that string, so I know what failed. That is a very powerful capability to have. On top of that, I have other cool features in Catch, and we'll talk about them. But the first thing is this. I don't have multiple asserts in Catch. I have just one assert, and that's it. And I can write code like the way God intended it to be. I don't need to use the right assert, because if I don't use the right assert, I'll get the wrong message when the test fails, don't understand, and need to debug it and waste my time. I just write code. And when that test will fail, and I'll cause it to, you know what, I'll take actually a different test that I want to fail. Here we go. When the tests do fail, I'll run it using ReSharp as well. It's nice to have a few options, especially in demos. So much information. Expression failed, and this is the name of the test. That's the thing I gave it here, so I know exactly what happened. And it shows me exactly what I was trying to do and what values were not what I expected to be. And that's powerful. And you know what? There's no reason Java and C# won't have the same capability, but they're not there yet. The next version of JUnit will probably feature this kind of behavior. But in C# I'm not seeing it happening yet. And I don't know why. Because they have reflection, and they can parse the code, and they can get much more information than C++, and they don't do that. They don't understand the world, I guess, as well. So that's a shame, but I did write something like that for C# because I was very frustrated with the need to use assert equal instead of assert true, instead of assert null. There's no reason I can't write my test this way in any language. But in C++, I guess it's also possible. And finally, metal. Metal, that was a fun one. This is what metal tests look like. Here we go. Go ahead. I'll define a suite of tests with some name. Well, first I've copied it. And I can use Lambda in order to define the actual tests. And here I have the first test. And, well, if you're comfortable with this kind of syntax, that's fine. And they're using strings-based as well. But that's easy. That's because they don't need to transform it into methods in the background. It's just lambdas that they run and just register the test. And here are everything. And that's fine. That's cool. And it has a main in the background that I don't need to write. And Catch has the same capability. I don't need to actually write a main method like I need to do, for example, in Google Test. In Google Test, there's something hiding here. I need to write a main method and initialize Google Test or Google Mock, depending on which I use, and then call run all tests, which is okay because I don't need to tell it exactly which test to run. Some unit testing framework will force me to tell it the test in some formal list or something. But I don't like doing that. I always forget what to write. And then I need to copy from an old project or Google for it. I don't like that. As I said, Catch has the same capability. If I go to Catch, somewhere will be written define Catch config main. That's defining the main method in Catch. You can do or don't use that. So that was a quick overview of unit testing framework in C++. Now, in the unit testing world, we have some dilemma. Usually when starting to write unit testing world, we don't understand the problem, but then something bad happens. Whether or not to write multiple asserts. Ever heard about the single assert per test rule? Anyone? Okay, yeah. I couldn't find it. I Googled for it for days, and no one ever called it the single assert rule. There is, I guess, no such thing. But there is a guideline, if you will, that if we write multiple assert in one test, we might doing the test wrong. And for good reason. Two reasons, actually. The first of which is technical. In other frameworks, not talking about C++, asserts will throw an exception. In JUnit or in NUnit in .NET, an assert will throw an exception, which means that if I write multiple asserts, the first one who fails will throw an exception, leaving me with less knowledge about that problem than I like. I want all the assert to tell me exactly what happened. Again, in JUnit, they're probably going to fix that, and then you need to have a proposal about that, because that's a technical problem, which should be fixed. But on top of that, writing multiple asserts could mean that I'm testing several things. It's a good way to write a very complex and readable test, if I test for a lot of things, and it's very, developers find it more to the liking in the beginning to write those kind of tests, because that's the way we write code. We initialize something, but we don't want to do it over and over again in each and every test. And then we test everything possible for that scenario, everything, including the weather. And that's not a good way to write unit tests. Remember, unit tests should be specific. I shouldn't write everything in a single unit test. So that's the reason multiple asserts are not good. But one assert per test has its limitation. What if I want to test a complex object I just got back? It is one result. I'm testing one thing. But my message object I just got back has an ID, a name, and a content, and I want to test them together. But if I'll test them together, again, not in C++, then I'll lose some information along the way. Oddly enough, in C++, I don't lose any information. The reason is that in C++, at least many of the unit testing frameworks has the ability, and this is Catch, but Google Test is the same way, to define two kinds of asserts. In Catch, you have require, which means the minute this specific test fails, stop the test. And we can see that in the test result. I'll run it again. And here I've created a bad test just to show it failing. It's not a good test. But the requirement failed, but I don't know absolutely nothing about the other two required. And that is a problem. But in Catch, I have something else, which is very similar, called check. And check is just like require. The only difference is that the test doesn't end once it fails. It continues to the next line. And Google Test has the same thing. It's called expect. There's assert and there's expect. If I assert that something is equal, the test will fail once that assertion fails. If I expect something is equal, the test will still fail, but only after the whole test will finish. Which means that now when I run the same test, we'll give it a few minutes to compile, then I have more information. I have two different checks that fails. Not only I have only one object instead of two, but also this is the name of that object. And by the way, there are better ways to test for arrays, but I needed a good example, so you have to forgive me for that. So in C++, we have capabilities that C# developers don't have. And that's the ability to use multiple asserts if we choose to use them. And now it's our problem to decide whether or not that's a good idea. And that's cool. There are other innovations in the C++ world as far as unit testing. First of which is what I showed. You don't throw an exception when an assertion fails. The second is that usually we get better failure messages. Better failure messages because the macro, the require assert macro usually does a lot more than the C# or Java does. And in case of Catch and all the guys that copy it, I have only one assert in which I write code. And as a developer, I find it to be so relaxing writing code instead of thinking about which assert to use. And the last thing, also brought by Catch, is sections. And section is a rather cool feature. Section give me the ability, if those of you who were here yesterday, I shown a demo called trip service. I'm testing a bunch of things. And I noticed that several things I'm checking tend to happen a lot of times. I have duplicate code between my tests, and that's okay. Tests are allowed to have duplicate code. I prefer the test to be readable than maintainable, because the maintenance of duplicate code in tests should be easy, because the tests are supposed to be quite simple. And going over 200 tests and changing some small thing is usually easier than extracting everything to methods and base classes and then trying to understand what happens. So in Google Tests, for example, the way to do it is to define the actual class. Remember, I told you that Google Tests create a class in the background. I can define that class. It needs to inherit testing test. And then I can have fields, and I can have a constructor and destructor, but I can also have setup and teardown methods, which will run before and after every test. So before and after every test, I'll initialize the fake objects I need and set the That's a singleton I'm playing with. For those of you who are yesterday, you might remember this example. And then I'll write the test, and in case of Google test, I'll need to run it with the _f. That's my way of telling Google test, this class was already created, please don't create another one. And then those tests become the methods of that class. And they can, just like writing code, right? I can reach the protected values, I can call methods which everyone who uses this class can use, and I can use the fake object, this is the fake object from above, and so on and so on. I find this solution, this is the solution that every single unit testing framework since JUnit did, called test fixtures. I don't like that solution. That solution means that my code, the test code, essentially is in two different places. The first is up here, and the second is down here. And when that test will fail, and hopefully it will, because that's why I wrote the test, it will catch a bug. I need to go like this several times until I understand what the hell happens. And if someone just wrote a new test and he needs something different to happen with the initialization, and he haven't thought it through, he will go and change something in my setup method and accidentally changing my test as well without any of us realizing it. And there are two outcomes to this kind of behavior. Either the test will fail, which is the good outcome. It means that I get to catch a bug. Or the test will continue on working and test something completely different from what I intended to happen. That's why I like a catch solution, which is sections. And for section, I'll just jump ahead. And the same test, the same fixture, written with section will look like this. After Visual Studio will stop refreshing itself. Here we go. Test case. Initialize whatever you want, and then you call a section. And what happened, this is essentially is a different test from the section below. They will run individually. If one fails, the other one passes. And they won't run one after the other. They will run in a different run. This one will run, well, maybe first or second. I don't really care about the execution order. And this one will run in a different run. It's not like a whole method running method one by one. And this is, I find it to be more trivial way, because I can see what happens in the test and then the section runs. So I have all my initialization code in the same place, and then I can run my code. Essentially, I've created the same thing I created with fixtures, but now it looks logical. It's easier to understand. It's easier to debug. Put a breakpoint, run on. And you don't have to a breakpoint upstairs in the setup and one inside, and it's very nice to use. And this is another innovation that is missing from other languages. Everybody uses test fixtures, and that's not a good solution. And unfortunately, I've yet to find a good way to do that in C#. But I'm still looking for it. So that was why unit testing frameworks. Let's talk about mocking. Mocking objects are something we need in unit tests because we want our unit tests to be isolated. I want to create objects I can control. Those objects are created usually by using inheritance. I inherit a class I don't want to call, the data access layer class, whatever, and I change it with my own class that does absolutely nothing. And they are called mocks usually. I call them mock objects for one reason only, for you to be able to Google for them, because personally I believe they should be called fakes. I find that the term mock stubs, test double, spy, whatever, to be very confusing and turn people away from using those kind of objects. Essentially, it's just a fake object that does absolutely nothing until I tell it to do something else, basically. And those frameworks that create those mock objects will probably use inheritance, although not sure about all of them, but most of them, in order to create another object that overrides all the methods of that dependency and create an object that does absolutely nothing. That's the first thing they give me. The second of which is the ability to change the behavior in that test. Just for that specific test, I want your object to return this value or for an exception or whatever. And I want it to happen only in the test, and once the test is over, I want you to forget about it. And that's the real benefit of a mocking framework. Because I could write those classes by hand. I could inherit the dependency and override everything. But then I need to maintain classes in my test, and I don't like to do that. And the last thing, the last capabilities of mocking framework is to verify that a method was called or wasn't called. In effect, assert that a method was called. Just like we assert that a value was equal 10, we assert that the database.save method was called with specific argument or not, depending on what we need. In C++, I have some good news and bad news. The good news is that there are mocking framework for C++. That's good news because that wasn't always the case. The bad news, but it changes, is that it used to be only one mocking framework, Google Mock. And it changes because people are changing things. And you need to be careful. A lot of the other projects are dead projects, not maintained anymore. Won't work for you. And if you accidentally use one of them and find out about it later on the road, then you might have a problem because you need to replace all your tests. And the ugly thing is that some of them require quite a lot of code written as well, and most of them are not, they change a bit of the AAA kind of way of writing tests. But that's because it's C++. So in C++ mocking framework, that's a shorter list. There's not a lot of them. There's Google Mock, comes with Google Test. Okay? Same limitations, same ideas. And then there's Trampolet, written by Bjorn, sitting here in the front row, which takes Google Mock ideas and improves them. At least that's what I think. There's HippoMocks. Unfortunately, I don't have enough experience to tell you whether or not that's a good idea. I noticed that it wasn't released in the last 2 or 3 years, so might be a problem. And there's Fakeit, which not sure if it's a cool side project or something I can actually use, but playing with it a bit, it has limitations, but it has some nice ideas going there as well. Let's see an example, shall we? So mocking framework comparison. I have here this calculator I showed it yesterday, and I have 2 dependencies. I'll read something from the database, and then I send that information to the client. I want to do 2 things. I want to affect how the data access return the data. I want it to return the data I care for. And then later on, I want to check that the client was called. So with Google Mock, basically, the test will look something like this. You write expect call. You first need to create a fake class. The fake class is a class that inherits a class I'm faking. And then I use one of those macros that will essentially create an overridden method in the background. You need to use that method to be virtual. If that method is not virtual, you should see the session I did yesterday. And then you write the method name, the return value, and the parameter. The number here is the amount of parameters. That's a limitation, not that bad. And then going back to the test, I use expect call of that fake data access. When the method getData is called, I want you to return this specific object. That's it. And I can also, here, I want to make sure that the fake client with this string is called at least once. And what Google Mock does is that once the mock object goes out of scope, the method ends in this case, it will check that that class was called at least once, which is cool. Moving on to Trampolet, which I hope I'm pronouncing correctly. It looks very similar, although because it doesn't have integration with Google Tests like before. First of all, I use Catch. But other than that, you need to create a reporter that will tell you the error, because we don't want to throw an exception like those C# frameworks. And then here I use the test case. And I also create a fake object, just like Google Mock. Look very similar. It's make, const, mock, but other than that, very similar. The benefit of using Trampolet is that you don't need to compile anything. It's a single header deployment. Just include it here, and that's it. And that's a cool thing to have, because compiling Google Tests and Google Mock can be a pain. And then you use allow call. There's allow call and require call, which is something I like. I don't want automatically, every time I set a behavior on a fake object like so, that the mocking framework will go and check that it actually happens for my good reasons. And by the way, this is what I think. Some other unit testing experts think the other way around. But I think that if for some reason someone will extract this method or change it or do something so it's called from somewhere else, or called more than once, I don't really care about that, because this method is only written here in order for the test to continue execution. and I don't want the test to fail because of that. So I'm using allow call and not require call, like here, where I do require that the call will be called exactly once. So that's something I like. And going on to fake it. Fake it, I'll show it because it's a bit different, and that's why I worry a bit. But in fake it, you don't need to write any classes. You just create a new mock of the type of the class, and that's it. You don't write any additional code. And that's weird. I'm not sure why. I don't know what they do in the background. And it has limitation, and they are documented. It won't work in any single scenario. It has problem with multiple inheritance and I think pure virtual methods. So keep that in mind. You might not want to use it if your code has those kind of things. And the syntax is very, very similar to what you expect from Java or C#. You have the when I said the behavior, when method get data, return data, just like before. When this is called return free. And then, other than going out of scope like the other two, it uses an explicit verify to check that this fake client was called at least once. And that's a matter of preference. You get to decide which one you like more, but you have to be careful. It's still being maintained, but there are limitations. You need to read them before you use this specific framework. So those are your options, basically. And you have to be careful with other tools. Just because I haven't spoken about a specific tool doesn't mean it's not a good tool. Just means that I haven't used it yet. And they might be good, but you need to go and check when was the last commit and when was the last release. If it was 3 years ago, 4 years ago, 5 years ago, don't use it. Another good way to check whether or not a library is maintained is read the documentation. If there is no documentation, you might have a problem. First of all, you'll have problem understanding how the thing works. Other than that, we developers, we don't like to write documentation. If someone took the effort to write good documentation, he cares about his library and he wants to maintain it. And since C++ is changing, now every 3 or 4 years C++ gains more capabilities, you want your unit testing framework and you definitely want your mocking framework to change alongside because things are changing as well. So if something haven't changed since 2004, you have a problem. All the C++ 11 features might not be supported. So those are good rules to think about when you need to choose your unit testing and mocking framework. Now a few words about Windows. If you are a Windows developer, that's good for you. You have a nice integrated environment to use. But I have good news for Linux as well. Windows is supporting right now the ability to debug code on Linux from Windows. You can run code on Linux and debug it from Windows. I'm not sure whether or not you can run the unit tests in this fashion, but I hope it will come. If it's not there yet, there are test runners to run from within Visual Studio. You saw me use ReSharper for C++, and Visual Studio as well has the ability to run tests. And you can also use coverage. And that's cool because coverage tools are very helpful when you need to understand whether or not you forgot to test something. For example, here, you see all the tests here? Those are Google tests. Those are not Microsoft tests. And they appear on the side because I've installed the test runner for Google Test. And there's one for Catch, and there's one for about any unit testing framework. And if there isn't one, you can write one yourself. It's not that difficult. And not only can you run the test from within Visual Studio, you can also run with coverage analysis from within Visual Studio. That means that if you're developing only on Visual Studio, you have a coverage tool as long as you have the right version. It's only supported in the high-end version, Ultimate or Enterprise. But once you do run the coverage, which I did beforehand, you can go to your class, open it up, and find out whether or not you passed all the pieces of your code. It doesn't mean that it tested everything, by the way. Just mean I ran through the code. It's more helpful to find out what I missed, not what I'm actually doing. And that's cool that you have it from within Visual Studio in C++. And let me tell you something. Visual Studio had the ability to run code coverage on C++ since at least 2003 that I know of. But it was a command line thing. You can only run it through the command line using MS Build. And that's very unfortunate. It's like they hid that capability. And now it's wide in the open, you can use it, and that's cool. But it does not mean that if you work in Linux, you don't have that ability. First of all, because you can now run from Windows to Linux. Second of all, you might decide that although your project is multi-platform, you want to develop on Windows and then deploy on Linux. I've been in several of those projects, and then you have those tools to use. So keep that in mind. In Linux, you do have coverage tools, some of which even is open source, but you have to hack it together. You have to add it probably from the command line in order to use it. So how do you choose your unit testing tools? First of all, your project. Is it multi-platform project or single-platform project? That will decide which one you prefer. Some people, I've been to a project where they prefer to use Microsoft native unit testing tool. It was easier. It's not well documented, doesn't have all the features that other unit testing framework has. I have to say that. But ease of use, that's what they have for them. But the other frameworks, ease of use is a thing. How easy is it to write a test? How easy is it to write a mock? Do I need to compile all my dependencies, my mocking framework, my unit testing framework, or just include a header file? That's a big thing to remember. What happened when the test fails? You want to know if you have a good unit testing framework? Run a simple test. In the assert, run 2 + 2 = 5. See what happens. How much information do you gain out of it? Are the test names need to be valid method names or just strings? Strings are better because you get to write whatever you want. Just make sure you don't write too much. And integration points. Sometimes I suggest using Google Mock because it comes with Google Test and they are well integrated together. And because there was no option before that, before 3 years ago. But integration points are important. Runner support, how to run the tests and how easy to deploy. And finally, personal taste. Some people like what I show you in Metal, especially in C++, all those templates and lambdas. I can find the charm in it. And some people prefer a Microsoft way of defining the class and then defining the methods underneath. Some like features, some like sections. It's up to you to decide. But the important thing to remember is that I have a friend who hates C++ with a passion, a very good developer. He told me in a lunch 3 days ago that he doesn't understand why the language just won't go away. Obviously, that's not going to happen. It's a very useful language to have. It's a very useful tool to have. So the way I see it, you have 2 options, and I've been there. You can, once things go bad and crash and you need to debug something late at night, you might curse and you might be very frustrated with C++. And you might blame the language for it. Or you can write tests. And avoid at least half of those problems, if not more. And that's up to you. Take that investment and decide what to do with it. Thank you for listening. If you have any questions, I'll be happy to answer. If not, I'll be around. Okay? You can check out the Pluralsight courses. You can see my details over there. That's the second QR code. And definitely need to check Oscode if you're a C# developer as well. Thank you for listening.